will divide into two different categories. One, the analyzing of the inputs and the functions. So the other is discussed and the algorithms. So if you need the hardware or if you need the algorithm, before we need the initial conditions and what are the inputs, how we are going to process all these things. So to get all these informations and to fix our hardware or software or algorithm need are inputs. So to analyze these inputs, the red color mark, whatever is there in the left, it will be useful. So first, we need to know about the image and video information. So what kind of video it is, what kind of image it is. That means it's not who is going to take and what the scene it has. It means what kind of information, how many bits it has to represent the colors, or how many frames it has to represent a video. Okay, what is the quality of the video and how much time it's going to process. So whether it is a real time or non-real time. So those are the major and first initial requirements for the image and video. The second one is the information. So I capture the video or frame or a image, so it has some information, whether this is a valid information or invalid information. So if it is a valid, what kind of color I has, or how many number of bit I has, or what are the information level I need to process. That means the accuracy of the information. So what kind of quality I need in the input and output. So between this input and output quality requirements, we need to understand. The third one is signal versus data processing. So this is the most and important one. So signal processing in the sense, it's kind of a signal which doesn't has a sensitive thing, or which may not has a valid data. So we can able to process, we can able to avoid so many of the samples. Something like in our analog signals, analog continuous time signals, between a time period, we have infinite number of samplings, infinite number of informations inside it. But finite number of information is sufficient to process or to understand the signal. Okay? So this signal processing, we can able to avoid, or we can able to take advantage of leaving some samples. But in data processing, we can't, because all the data which we have are sensitive and it will be required. So if some of the data get changed, or some of the data get corrupted, or some of the data get lost, the entire flow or the entire output definitely will be wrong. Instead of processing a voice, in case it misunderstood as something else, or even the voice signal, if it is misunderstood as a noise, then it will be a problem. So the corruption of the data, or leaving the data, it will be difficult for us. So the next one, features and the domain. So it means whether I'm going to process the inputs with the same domain or the different domain. So what does mean by domain in the sense, sometimes the signal in the processing domain itself. Something like we are keeping a markup. So directly we can able to see what markup we kept. So, but it will not be that much effective. Within 1 day or within 2 days, it will go away. But instead of that, I can able to change my lifestyle, which will not affect my look. So slowly my look will get changed. Even I didn't keep markup, I'll get changed. But this is not the direct applying. I'm keeping in some other domain. I'm changing my lifestyle in some other place. So what actually okay. So this domain in the sense, this is something like whether we are processing in the same timeline or the virtual timeline, which is not available physically or which we can't able to see directly. So the next one, quality versus accuracy. So in case if I'm processing in the same domain, I know what kind of changes I'm going to make. If I make this change, what will happen? But in case if I'm changing in some other domain, I don't know what will be the reflect I'll get. Sometimes it may be positive, sometimes it may be negative. So I should be very careful when I go for the some other domain. So why I need to go for the some other domain, or why I need to process? I need to understand. So there it will define your quality or accuracy, and the processing time and the signal time. So this is something like between your input and the output. Something we'll say as a throughput or delay. So what rate we are receiving an input and what rate I can able to produce output. So that is my processing time versus signal time. So these are the input standards we need to analyze. So once we analyze all these things, we'll get some information. Based on this information, we have to decide what kind of hardware or what kind of algorithm we need to keep. So without analyzing this, definitely we can't say which kind of algorithm or which kind of platform I'm going to work on it. Okay? So based on this, the platform, whether you need a hardware or whether you need a software or whether you need a hybrid of this hardware and software combination. So, and the next, the sensors, it's something like input and output modules. Whether I need the input and output modules or I can able to process inside the system itself. So the input, whether it will be generated in the system itself or whether the output is needed only for the system itself. It's not for the human functions. So something like that if we need to analyze. Based on that, we can optimize our algorithm and platform again. So the next is the algorithm. So most of the time we heard about this serial, parallel, partial parallel, pipelining, all these contexts. So we need to understand all these things, whether I need a serial algorithm or a parallel algorithm, whether this algorithm is suitable for the defined platform, something like software or hardware. So in case, if I'm choosing a software kind of algorithm, mostly your serial algorithm will be a better one. Okay? So why it's a serial algorithm is most of the time our software language codes will work based on our instructions. So instruction by instruction. So it can able to do one operation and then second operation and then it will reuse the hardware. So if it is a algorithm is serial, it will be better enough to handle with the software. But in case if it is a GPU or kind of parallel programming, then based on your hardware, we can go for a partial parallel. It's not complete serial or complete parallel. We can go for a partial parallel. So partial parallel in the sense, maybe you may get multiple input sets at a time or else a partial of the input sets at a time. That is partial parallel. Something like per input at a time if I'm processing, that is called serial. It's correct? So if I have 10 inputs for a set, all 10 inputs if I process, that is a parallel. In case partial parallel in the sense, I may get more than one input, less than or greater than 10 inputs. So in that case, more than one inputs if I get, less than 10 inputs if I get, I can able to process partial of the input, I can store it, again I can reuse the hardware, I can process for the next set. Similarly, if it is more than 10 inputs, it's more than one sample or more than one frames, okay, or more than one complete data set. So I can able to process all this at a time and I can preserve the remaining for the next set of processing. So this is called partial parallel. The next, implementation. So this implementation will define how you need to define your algorithm, whether mathematical point of view or logical point of view. So mathematical point of view in the sense, you need all the mathematical concepts, all the formulas and all the background data processing and signal processing algorithms, everything. So based on this, you can able to define your function and you can able to say what kind of changes it will happen. If it is logical in the sense, sometimes I will not know what kind of mathematical functionality it has, but I know something like if-else statement or for. If this condition is there, you do this. If this condition is there, you do this. Or until this condition, you do this. So kind of this statements I'll be end up with. For this statements, what are the exact mathematical functionalities are there? I don't know. So something like that if you have, you can go for a logical. But for the better system design, it will be a combination of both. Because sometimes you need a logical thing is a better one. Sometimes a mathematical thing will be a better one. So the next, the quality, which is actually we have to say about the controllability and stability of the function and the algorithm. So how much the function is controllable or how much the function is stable for the given set of inputs. So this quality also will define in case this is this entire flow is for the hardware functionality. In case if I'm creating on hardware here now, it means I'm going to create on chip. So in future, I need to use the chip at least for some years. But after some years, if the chip is still in working state, but the input conditions are changed, still I have to throw the chip. Something like our internet system or our mobile phone. Previously we have a 1 GB mobile, now 1 GB of RAM, now it's still 64 GB of RAM we have. So even internet speed, previously 2G alone we have, now we are in 5G. Okay, so the speed or the amount of data which we need to process is changed, but the background processing system is still fixed. So in case if the system can't able to process this amount of data, this many amount of data, then in the system, even if it is, we need some kind of pre-configured programmability or some kind of provisions to reuse the hardware until the end. So that will define your quality of the function. Okay. Okay. After the break,